Hello dear student, welcome to the 7th lecture in programming in C++. In this video, we will learn about the overloaded function, inline functions, default arguments, scope rule for functions, and about storage classes. In the previous video, we have learned about user-defined functions, that we as an user can define functions which is not available in the built-in functions or in the library functions. We have defined many other functions such as making a sum can be defined, arranging a number can be defined, different functions can be defined by the user, and we should declare a function and later on define a function using the arguments and function variables and also function name. So far we have seen how to declare or define a function and use that in a C++ program file, the source file. In this video, we will learn how we can manipulate these user-defined functions so that this can be more convenient for us to use. And such a very good manipulation which we use constantly in C++ programming is function overloading. Function overloading is a feature in C++ where two or more functions can have same name but different parameters. Function overloading can be considered as an example for polymorphism feature in C++. Remember, we have defined a function sum in the last video. If we can use the function is defined using a data type and the function name and the parameters. If in function overloading, the data type, that is the return type, and the function name will remain the same, but the parameters can be different. For example, if the first parameter was int, then in the second parameter it can be float, or in the third it can be character, or etc. That is, the type of the parameter can be varied while keeping the function name as same. And this is the feature known as function overloading. The advantages of the function overloading is that it eliminates the use of different function names for the same operation. For example, we need to sum two integers, then we can define a function return type as float, int, or anything as a return type, and the function name sum with parameters int, int within the parentheses. I hope you remember how we defined it. And in the next function, say I have to add two floating point numbers also. So instead of defining another function, I can declare using the same function name but using different parameters. So in effect, I am defining two different functions, but these two different functions have the same name, that is sum, so that my function will look more easier. That is, when I look into the source file, I will immediately identify that this is a function for summing two integers and this is a function for summing two plots. I need not search for different names to define different functions, only I have to change the parameters. And thus it eliminates different function name from the same operation. The next advantage is help to understand and debug and grasp easily. See, when we are writing a big function, a source file can be very lengthy. So debugging and understanding, maybe error correction, troubleshoot will be very cumbersome when we use different function names for the same function. Maybe the sum will be the function, but in the first case I have to sum two integers and in the second case I have to sum two floating point numbers, and for every function of sum, if I give another names, such as maybe for the first function I give a function name as sum, and for second I give a function name as add, or maybe anything else, and the debugging or the troubleshooting of the program will become more and more cumbersome. This method of function overloading is used to make my source file look more simpler so that I can troubleshoot with ease. And the third advantage is the easy maintainability. I can just look into my source file and see what is a function and what does it stand for. Consider this example. In this example, here you can see that there are two functions with the same name, print. Here you can see that there are two functions. There are actually three functions with the same return type, void, with the same function name, print, but different parameters, that is int I, double F, constant character C. So these three functions actually are three different functions, but it all serves the same purpose. They are used to see out something, to print something. So instead of writing void print int I here and repeating the same over here, if I give another name such as print out, and in the same I give print character, then the my program will look more and more cumbersome. So instead of using different file names, I can use the same file name just by changing the parameter as int I, double F, or constant character C, etc., so that my source file would look simple. So if my entry is an integer, then it will print, it will come to this function, and it will run this function. If my entry is a floating point, then this defined function will be executed, and if my entry is a character, then it will execute this function. So the function is very clear. It is three different functions, but in using the same name for my convenience. Now let us look into inline functions. Inline functions are also another type of manipulators we use in the user-defined functions for my program to look more simple and effective. Inline function in C++ is a very powerful concept, and that is commonly used within the classes. If a function is inline, the compiler places a copy of the code of the function at each point where the function is called in the compile time. That is, if I define a function and if I use the same function name at different points, that the compiler copy paste the function definition in every point I call upon the function. To inline a function, place the keyword inline before the function name and define the function before any calls are made to the function. We know in the previous video we have said that we can first declare a function and define a function later on, maybe after the main program. But if you are going to inline a function, then make sure that the function definition comes right before any function calls. In the previous video, we have declared a function. After that, we have made the function calls, and in the end, after defining the main function, we have defined a function. So in this case, if you want to inline a function, then the function declaration and the function definition have to come in the front before the function calls are made. The compiler can ignore the inline qualifier as a case defined function is more than one line. Let's look into some of the examples. The advantage of an inline function is that the size of the code is considerably reduced. That is, instead of writing functions at different points, we can just copy paste the same function just by using a single word in line, and this reduces the length of my source file considerably very low. This increases the execution speed also. As you have noticed, when we run a large program, the execution will take a bit delay, and if the source file is very small, the execution and the compiling time is very small. So since this reduces the size of my object code, that is the program file, the project file, my execution speed is also increased. The inline member functions are compact function calls. They are function calls, but they are compact in nature. Here is an example for inline function. Here I have inlined a function max int x in y. See, before the function return type int, I have added just a word inline, and I have my function name max and my parameters int x and int y. And inside the main function, I have called this function several times, that is max 2010 for max 0, 100, 200, for max 100, 1010, etc. For several functions, for several steps, I have called the same function without change in its values. That is, instead of defining function for every step over here, I have defined just one function with a single name in its before as inline, and used that function several times. So instead of writing pages of source file, I can just make it very short, and just by using a single name inline and use that user defined functions many times inside my main function. Now let us look into default arguments. As we know that we give arguments in our user defined functions, and sometimes we initialize our arguments also, such as I is equal to 0 or int x is equal to 0. Even though we do not initialize in its parameter, in its declaration, we will definitely initialize those parameters in the function definition. Suppose in some cos file, in the some user defined functions, the parameters are not initialized, the parameters are not given the initial value, then the compiler itself will give some values for that parameters for the smooth running of the program, and such arguments are called default arguments. A default argument is a value provided in a function declaration that is automatically assigned by the compiler if the caller of the function doesn't provide a value for the argument with a default value. Hope you are clear with default arguments. Let's move on to scope. Scope is mainly defined using variables. Hope you remember we have used and declared many variables, for example int, sum, int, x, y, float, a, b, etc. All are variables. We have defined many variables inside our user defined functions also. Hope you remember inside defining the user defined functions, we have given certain variables such as I or end. We have declared such variables also. So there are different types of variables we use in a source file, and those variables have a scope or the reach. What do you mean by out of the scope of a syllabus? That means that the question came when the question came was not defined inside the syllabus. That is when we say that the question was out of the scope of the syllabus. Just in the same as the scope, the word scope is used here to define whether a variable exists inside a particular region or not. And in the case of C++ program, we have different regions with different areas in which we define variables. The first is built-in. That is, there are many library files, many header files, and we have many built-in variables and built-in functions. For example, if you type sqrt, this means square root. And you do not need to define sqrt as a variable because the compiler already knew that there exists a variable sqrt as the square root. So you do not need to define such a variable. You do not need to define cout. You do not need to define cin and many other keywords that we use inside a source program because it is already been defined. And these code words do not change from program to program. I can use these same code words in every program I write. So it is defined in a global space. That is, in an entire program in C++, I can use these variables. Such variables are called built-in variables, and they are there which exist inside the library files or the header files, and I can use this, access this in all the source files I write. The second type of variables are global variables. Global variables are variables which I can use inside a source file. Suppose I have written a source file, and inside a source file, you know, there are main functions, there are user-defined functions, there can be many other functions. If I define a variable such that this variable can be used inside the main function, inside the user-defined functions, and everywhere inside that particular source file, then that variable is known as a global variable. The next type is a local variable. A local variable is a variable which is defined inside the main function. That is, when we type int main and we give a open and closing the curly braces, and inside that curly braces, whatever variables are being defined are local variables. So far we have defined many local variables. I think most of the variables we have defined are local variables, and these local variables are defined inside the main function, and I can use these variables throughout the main function but not outside the main function. I repeat, if I declare a local variable inside the main function, then I cannot use that variable outside the main function. Such as outside the main function, if I have written a user-defined function, then I cannot use that local variable in the function definition which is outside the main function. So if I have to use the same variable, I have to declare again the same variable. I can't use the variable declaration which I've already done in the main function. The last type is a function, file, or the block. Such as we have made a user-defined function, and I'm defining the function. While defining the function, I use different kinds of variables, and that variables are specifically used for that function only or that block only. The block, I mean whatever statement which is written inside two curly braces is what I define as a block. So that variables is defined inside that block only, and if I call that variable outside, anywhere outside that block, then the program will show an error. So there are different types of scope of function. There are built-in functions, built-in variables, which can be used in all the source files which I write in C++. There are global variables which can be used throughout a source file. There can be local variables which can be used only inside the main function, and there are function variables or block variables which can be used inside definite blocks or definite user defined functions only. Consider this example. Here, before the main function, this is our main function. So before the main function, there are certain declarations, certain variables are declared: integer, character, string, int, number, etc. are defined before the main function. So these variables, integer, character, etc. can be used throughout the program, and these variables are called global variables. But inside the main function, we have defined certain variables such as short age, a number, b number, etc. Then these variables are called local variables because they are used inside only the main function. For example, if I call the variable short age outside the main function for any other user-defined function or any other function, then the program will show an error. If I have to use a variable inside the main function and outside the main function, then definitely I have to declare it outside the main function as a global variable. Now let us look into what are storage classes. Storage classes define the scope of the variables, that is, where the variables occur and what are the functions of those variables and where these variables are actually stored in a C++ program. As we know, we take an intake in cin when we use the function cin, we extract data, right? And we extract data and we store them in certain variables. So we can tell the compiler where to store a variable such that maybe it can be in a register or it can be in a static or extern, etc. We can actually tell the compiler where to store that variable. And these are used with specific specifiers such as register, auto, etc. are specifiers which tells the compiler to store the variable month, that is, store whatever data which is coming into the variable month as an auto storage class. And this line which says that to store it in a register storage class. There are many storage classes in which we can store a variable. Now, what is an auto storage class? Auto storage class is a default storage class. That is, when I define a variable int age semicolon, then whatever data which comes into that age is definitely stored in the auto storage class. That is, it's an automatic storage class and it is used in the class and it's used in the local variables mainly, and which is used within the functions, and it goes directly to the auto storage class. The next storage class is the register storage class, and it is used to define local variables that should be stored inside the register instead of in random access memory. This is stored in a register instead of the random access memory. To store a variable in the register class, the maximum size of the variable should be the size of a register. That is, usually a word size is maximum that we can store in a register storage. So our data should be should have a maximum size of that of a word and not more than that of a word. Also, in register storage, we cannot storage the AND operator because there is no storage space for this AND operator in a register. So the data should not contain this AND operator. These register storages are used when we need to have quick access to that particular data many times. That is when we store these data in the register storage, such as in counters or maybe in some examples like that. We need to store data and we need to have quick access to that data many times while running the program. So such data are stored inside the register storage class. The next storage class is the static storage class. A static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program instead of creating and deleting them many times. The storage class once created for the static storage class will remain static until the compiler compiles and runs the program completely. The storage area which is created is not destroyed after using after that particular line has run. Usually the memory is dynamically allocated. This is a function, this is a property we have learned in our first video. Hope you remember in C++ features we have learned that there is dynamic allocation of the memory. That is, memory is not static in C++. This memory space can be used for different materials to be allocated at different times while running a program. But if you need some memory space to stay static for a particular variable, then you have to define that variable using a specifier static in front of that variable. The next type is the extern storage class, and it is used to give a reference to the global variable that is visible to all program files. The extern modifier is most commonly used when there are two or more files sharing the same global variable. I have already said you what is a global variable. Global variable is a variable which I can use throughout a source file. Suppose there are two source files which uses the same global variable. Then I can store that global variable in an extern storage class and say the compiler to save this storage class extern, save this global variable for another source file also. For such cases, I save my variable in the extern storage class. That is, my global variable is when it is used in two or more source files instead of being one. Then I store my variable in the extern storage class. The last type is the mutable storage class. Mutable specifier applies only to class objects. It allows a member of an object to override a constant member functions. Hope you remember we have learned about class and its objects. We define a class, and inside a class we have several objects, and all these objects inherit the properties which is defined in the class. We have defined the feature of inheritance in our first video. Hope you remember. So we have a class, and inside the class we have several objects, and all these objects inherit all the properties of the class. So suppose I have defined a function as a constant variable in a class, and inside the object I want to override that constant variable and change the variable. Then I have to define that constant variable which is defined in the class as mutable. That is, I am telling the compiler, yes, this is a constant variable, this cannot be overridden, but in some cases if needed, then allow the program to override that constant function. That is when I define my variable in the mutable specifier. So what are the storage classes? There are auto storage classes, that is when the storage class which is automatically used. There are register storage classes used for quick access. There are static storage classes when we ask the compiler to save that memory location for that particular variable only. There are extern storage classes, that is when my global variable is shared between two or more files. And there are mutable storage classes which is used in the class objects when we have to override a constant variable. Therefore, in this video, we have learned about different manipulators that we can use in function declaration so that my function, my source file would look pretty simple and easy to troubleshoot. And those are overloaded functions. What are overloaded functions? And those functions which have same function name but differ in their parameters. There are inline functions, that is I can use the function several times inside my main function just by giving a name inline before the declaration. There are default arguments, that is if I doesn't give an initial value, the compiler itself will give an initial value to my arguments, that are default arguments. There are scope rules, that are my variables have different scope. It have a global scope, it can have a local scope. I can define my variables such as my scope can be defined. The area in which these variables can be used can be defined. That is the scope of the function. And towards the end, we have learned about storage classes, that are to which storage class we need to specify our variable. And there are different storage classes and we use these storage classes for different functions. Hope you are clear with these ideas. See you in the next video. Thank you.